hopefully everybody can hear the sound on this video. If anybody isn't and they're just seeing this, hopefully they're getting their sound set up. This is the video for Chapter 3, Section 5, Part 1, out of the Chapter 3 study guide for geometry. Now, 351 is talking a lot about how to write equations for lines. And first, basically, you need to know that there's different ways to write equations for lines. The most common one used in high school is called the slope-intercept form, where we have some symbols and variables, the equal sign and either a plus or a minus, and then we have an xy variables, and then the other two elements are actually numbers. M is going to be a number that is the slope number, and B is representing another number, which is the y-intercept number. It's the position on the y-axis where the line crosses through the line of the axis. The other way to write an equation for a line is called standard form. Well, there's others, but another way. It is where you have a number, coefficient A with x, plus numerical coefficient B with y, equals constant C. So A, B, and C are numbers. Now, I don't believe in this section we're going to be using standard form. I think we're just mentioning to let you know that there is more than one way to write the equation for a line. So, let's take a look at these equations. As you can see, examples 16 and 17 are in standard form. Or sorry, not standard form, slope-intercept form. You have a y equals the slope, which in this case is -7, and then plus 2, which is your y-intercept. That's where we'll start. We'll start with the plus 2. Your y-axis is here, so your y-intercept would be at 2. 0, 1, 2, 3. Then the slope of -7, we would write it as a fraction first. The top number tells us whether we go up or down. Since the negative is attached to that, we're going to move down. And the bottom number tells us whether to go left or right. Since it's positive, we will move to the right one. So from here, we'll go down 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Now, we went off the graph a little bit, that's okay. And then right 1. So we end up right here. Technically, I don't need this point on the graph. Okay. So that is our line. By finding these two positions that the line goes through, we're able to connect them. Don't forget to extend it on each side with arrows and make a line. Now you can see that mine is a little squiggly. It's not perfect, but that's okay. Your teacher just wants to know that you can tell them where the line is. It doesn't have to be exactly precisely perfect. This one, again, is written in slope-intercept form. You have a y-intercept of 4. So on your y-axis, you'd go 0, 1, 2, 3, 4. That's where your line crosses through the y-axis. And then the slope on this one is 5. So in order to count this out on the graph, we'll first write it as a fraction. Your vertical movement of 5 in the positive direction means we're going to go up. Your horizontal movement of 1 in the positive direction would be a movement to the right. Right is positive and left is negative. So from here, I'm going to go 5 up. 1, 2, 3, 4, 5. Again, we're kind of off the graph here. I'm just kind of estimating how long these squares are. And then 1 to the right would put me right here. So I'm going to connect these 2 points. And there you go. Now, I'm going to check something here and see if we're using the format for number 20 at all. I don't think so. Check one other thing. So I think we're basically sticking within the parameters of your slope-intercept form. I really don't see any call to go into the other formats of lines for this one. So, okay. Alright, so what are we going to do? Let's talk about example number 1. Example 1 says that we can write an equation of the line in slope-intercept form. Now, I need to simplify these first. Doesn't look like it. Okay. Well, I would say that we need to find two things. We need to find this number, which is our slope number, and we need to find this number, which is our y-intercept number. Well, it's pretty clear that if you count 1, 2, 3, your y-intercept number is 3. Goes through the y-axis at position 3. So really all we need to do is find the slope. So you can do that using your formula. Identify x sub 1, y sub 1, and x sub 2, y sub 2, and then use your formula that we covered in section 3.4 pretty extensively. Or you can count it out like I was doing up here. So from here, I would have to move up 1, 2, 3, 4 units for every 1, 2 unit I move to the left. Units move to the left. So my slope is up 4, which is positive 4, and left 2, leftward movement is negative. So if I can divide these, I should. 4 divided by negative 2 is possible. That's negative 2. So my slope is negative 2, and so the equation for my line is complete. I just fill in the other pieces that never change. Y equals negative 2x plus 3. These are more examples of this. If we want to find an equation for the line in slope-intercept form, again that's in y equals mx plus b form, we can do that. We would identify our b value, that's the number on the y-axis where the line crosses through, and then we would also want to find our slope by counting out the squares. So it looks like my b value here is 1. That's my y-intercept. My slope value, for every 2 units that I move up, I'll have to move 1, 2, 3 units to the right. Up is a positive movement. Right is also a positive movement. Remember, the first number on the top of your fraction is always vertical, whether going up or down, and the second number is always your horizontal, that's left or right. So if I put these together in y equals mx plus b format, I get y equals 2/3 x plus 1. Some students ask me, does it have to be a plus here? Well, not necessarily. You can keep it the plus there always, as long as you simply write this number down here. It could be a negative 7, in which case this would be plus negative 7, something like that. But yeah, you can always put a plus there, and then whatever this number is what it is. Whether it's positive or negative, you write it as it is. Example 2, my y-intercept looks like it's at 2. Here's 0, 1, 2. So I'm going to say my b value here is 2. On this graph, it seems that I'm going up 2 units for every 2 units I move to the left. So my slope is positive 2 on the top for moving up, and negative 2 for moving left on the bottom of the fraction. If I can divide these, I should. 2 is divisible by negative 2, so I'm going to go ahead and divide. So my equation is y equals slope number times x plus intercept number. And finally, the third example, my y-intercept, well, it looks like it's a 1.5. So I'm going to say that my b value is 3/2 or 1 1/2. You could write it as a decimal. I tend not to do that. And then your slope value, it looks like you're moving up 1, 2, 3 units for every 1, 2, 3, 4 units you're moving to the left. So up is a positive number, and 4 is going to the left is a negative number. This fraction cannot be simplified, so my answer is y equals negative 3/4 x plus 3/2. 3/2 is the same as 1/2. Notice I moved the negative off of the 4 and I just put it in the middle. With fractions that are negative, you can either put them on the bottom, put the negative sign in the middle, or put it on the top. As long as there's just one negative sign, you can either have it here, here, or here. A lot of time with our final answers, we just move it to the middle part of the fraction and write it like that. Now, point slope form. Again, I don't think we're really quizzing on that, but basically that's yet another way to write an equation for a line. So far we've talked about 2 of them: slope-intercept form, which looks like this, with numbers here and here; standard form with numbers here, here, and here; and then point slope form, which looks basically like this. You have y minus this, which is a y sub 1 value, that's part of a coordinate point, equals your slope number times x minus x sub 1, where x sub 1 and y sub 1 is a point on the line, and as you're probably well aware, m is the slope. Okay. So, for example 7, 8, and 9, what we're going to do is we can find the equation of the line using this technique of the point slope form. So, okay. So, if this is my x sub 1 and y sub 1, and this is my x sub 2 and y sub 2, remember that these are called ordinal numbers. This is the first x and y that I see, so that's why it's sub 1, and this is the second x and y values that I see, so that's sub 2. To find the equation for the line, I'm going to write my final answer in slope-intercept form, so I'm going to do the same thing as I did up here. I'm going to try to find a slope, and I'm going to try to find an intercept. So, here's one technique of going about doing that. Getting it into slope-intercept form. If I have, if I want to even write it in point slope form or slope-intercept form, either way I'm going to have to find my slope, which is m. So that's kind of one of my major priorities. I'm going to go ahead and find the slope. Y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 gives me negative 2 over 1, which is negative 2. And then if I want to put it in point slope form, that would be y minus one of the y values in the points that I've been given. I'm going to choose this one. That's y sub 1, so that would be 0. I'm following this format right here, y minus y sub 1, okay? Equals the slope, which is negative 2, times x minus the x value of the first point, which is negative 1. Notice this minus is from the formula, and then the number after it is negative 1, so it's minus negative 1. Y take away 0 is just y. And then when you minus a negative 1, it's just adding positive 1. So we actually almost have a slope-intercept form. All we have to do is use the distributive property here. Multiply through with negative 2. So I get y equals negative 2x plus negative 2. Now if you left it in this format, that would be point slope form. But if you change it to this format, that would be slope-intercept form. So let's try a couple more of those just to see if you can work ahead of me and maybe do it on your own. I'm going to call this x sub 1, y sub 1, x sub 2, y sub 2. Finding the slope, that would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which gives me 9/6, which reduces, if I divide both the top and the bottom by 3, to 3/2. So y minus y sub 1 would be y minus 4. Again, I'm using the formula up here. Equals the slope, which is 3/2, times x minus x sub 1, which is 0. So this will be y minus 4 equals 3/2 times x, because x take away 0 is still x. And then this would be your answer if you wanted to leave it in point slope form. But if you wanted to get it in slope intercept form, we're going to have to do something called solving for y. The y value in slope intercept form is all by itself. You can see here you've got a -4 attached to it. So in order to solve for y, we would add 4 on both sides. And then as you can see, this looks like our typical slope intercept form. Here's the slope value, here's the y-intercept value. So if you want to pause the video and just try number 9 on your own, go ahead and do that. I have x sub 1, y sub 1, and x sub 2, y sub 2. So my slope would be 2 minus 5 over 8 minus 4, or -3/4. So y minus y sub 1 would be y minus 5 equals the slope, which is -3/4, times x minus x sub 1, which is 4. So I'm going to use the distributive property here to multiply through. So I get -3/4 x plus, because we multiply negative times negative, you get a positive. If I multiply 3/4 times 4, what happens is the 4 on the top cancels with the 4 on the bottom, and you just get the number 3. Again, a negative times a negative is a positive, and 3/4 times 4, written out the long way, you can cancel the 4's and just get 3. Now we're not quite there. If you want to leave your answer in point slope form, you could have actually left it just like this. This is point slope form, final answer. I'm moving forward from that and I'm writing it in slope intercept form. So I'm trying to solve for y and simplify on the right side to get rid of the parentheses. I'm almost there. All I really need to do is add 5 on both sides, and my final answer in slope intercept form would be y equals -3/4 x plus 8. And that, I believe, is lesson 351, chapter 3, section 5, part 1.